guys, my name is Craig and welcome to Peri Solutions. In today's video, we're going to look at how we solve equations and inequalities of modulus functions. But before we start, please make sure that if you're new to my channel, you hit the subscribe button and turn on the notification bell so that you don't miss out on any new videos. So we're going to do this by squaring both sides of the inequality or of the equation. That's the method that we're going to use. And in the previous video, we looked at how we solve equations and inequalities of modulus functions by the graphical method. So let's start off by looking at this example, right? So like I said, the method that I'm going to use here is by squaring both sides of the equation or the inequality. So for this example, we need to solve for the modulus of x plus 3, 4x plus 3 being less than the modulus of 2x minus 1. So squaring both sides, we've got 4x plus 3 squared being greater than 2x minus 1 squared, right? And then now if we expand, we've got 16x squared plus 24x plus 9 being greater than 4x squared minus 4x plus 1. And then if we take what's on the right hand side to the left hand side, we've got 16x squared minus 4x squared to get 12x squared, then plus 24x plus 4x, we've got 28x, then plus 9 minus 1, we've got plus 8, being greater than 0, right? And then now, if we factor out 4 here, we see that we've got 3x squared, 3x squared plus 7x plus 2 being greater than 0. Then of course, if we divide both sides by this 4 here, we still get a 0 there. So it's just as good as removing these brackets, like this. Then now if we factor out, if we look for the common factor here that we're going to use to factorize, we see that we've got multiplying the first and the last, we've got 6x squared. And the two factors that we need are 6x and x. So 3x squared plus 6x plus x plus 2 greater than 0, right? Such that factoring out 3x, simplify this 14 expression, we've got x plus 2, and then factor out a 1 here, we've got x plus 2 as well, being greater than 0. So we've got x plus 2, factoring out x plus 2, and then we get 3x plus 1, being greater than 0, like this. So now, if we say we want the region for which y is greater than 0. So now if we have to come up with a quick sketch of what we would have there, of course, solving for x, we will have x being equal to minus 2 or 1 over 3, right? Minus 2 or 1 over 3 here. Such that if you have to come up with a quick sketch of what's happening, we know that there's a quadratic equation for which the coefficient of x weight is positive. So thus, the shape is definitely going to be cup-shaped, right? So for the points of intersection, minus 2 and 1 over 3, we've got minus 2 and 1 over 3. So it will be something like this. But what do we want? We want the region for which y is greater than 0. For which y is greater than 0, we've got this region here and that region here. But what do we see about these two regions? This region is the region for which x is less than, right? For which x is less than minus 2, right? And then this region is for which x is greater than 1 over 3. So now this becomes the solution to our answer, right? X being less than minus 2 and x being greater than 1 over 3. So this is how we solve this inequality. Now let's move on to look at this exercise. For number 1, we're required to solve the equations algebraically. And of course, we're going to do this by squaring both sides, then solving for x. And then number 2 requires us to solve these two inequalities algebraically as well. And this by squaring both sides. So now I shall erase this part here. Okay, so for number 1, we've got 1a, we've got x minus 3, the modulus of x minus 3 being equal to the modulus of x plus 1. Right, so first step is to square both sides. x minus 3 squared is equal to x plus 1 squared. Then next step, we shall expand. So we get x squared minus 6x plus 9 being equal to x squared plus 2x plus 1. Then if we take, now we have to be a bit smart. If we take, we see that x squared, we've got x squared on both sides. So whether we take this side or this side, we still get a 0. So this goes, x squared goes. And then now if we take minus 6x to this side, we've got 2x plus 6x. Then if we take 1 this side, we've got 9 minus 1. Such that 8 is equal to 8x and x is equal to 1. So that's the solution that we get for number 1. And then if we'd like to prove, here when x is 1, we've got minus 1 minus 3 to give us minus 2. And then when x is 1, here we've got 1 plus 1 to give us a 2. Modulus of minus 2 is the same as the modulus of 2 because we simply get a 2. Now let's move on to part B. Part B requires us to solve for x. Sorry, 3 multiplied by the modulus of x minus 4 is equal to the modulus of x plus 2. So now we square both sides. But now be careful, this 3 is not part of the modulus. But what do we mean by squaring both sides? We're going to square literally what's on this side and what's on that side. So 3 squared, we get a 9. 9 multiplied by x minus 4 squared to give us x plus 2 squared. Right? And now if we expand here, we're going to get 9 multiplied by x squared minus 8x plus 16 being equal to x squared plus 4x plus 4. This simplifies to 9x squared minus 72x, then plus 9 times 16, 4, 5, 144. This is equal to x squared plus 4x plus 4. Right, and then if we take what's on the right hand side to the left hand side, we've got 9x squared minus x squared to get 8x squared, 8x squared. And then minus 72x minus 4x, we get minus 76x. Right, and then plus 144 minus 4, we get plus 140, like this. And this will give us a 0. Right, and then now let's see what we can factor out here. So of course, we can factor out a 4, possible. So we can factor out a 4 here. If we factor out a 4, that we're going to divide both sides with, and still get a 0 this side. We'll get 2x squared minus 19x, then plus, this is a 4 again, okay? So this plus 2 there, 3, and then we've got 2, 5. Alright, 35 to give us a 0 there. And then now, of course, we can solve for this. Right? Multiplying those two, we've got a 70x squared. And the two factors that we need to get a minus 19x, minus 14x, and minus 5x. Right, such that we're saying 2x squared minus 14x minus 5x plus 35 is equal to 0. And solving for the 14 expression, factor out 2x here, we get x minus 7. And then minus, factoring out 5 here, we get x minus 7 to give us a 0. Then factoring out x minus 7, we get 2x minus 5. Right, and then we're saying either x minus 7 is equal to 0, or we've got 2x minus 5 being equal to 0, such that x is equal to 7 or 5 over 2. So these are the solutions that we get for x being equal to 7 or 5 over 2. Okay, now let's move on to number 2, which requires us to solve the inequalities algebraically, right? So, what is this? Like this. Okay, so number 2a requires us to solve the modulus of 2x minus 3 being less than the modulus of x. So first step, if we square both sides, 2x minus 3 squared, right, being less than x squared, then expand, we're saying 4x squared minus 12x plus 9 is less than x squared. Taking x squared to the left hand side, we've got 4x squared minus x squared to get 3x squared minus 12x plus 9 being greater than 0. Right, then factoring out 3, which we shall divide both sides by to get a 0 as well. We're simply saying x squared minus 4x plus 3 is less than 0. Then now solving here, now we need to factorize. So we're simply saying we've got x minus 3, x minus 1 being greater than 0. Coming up with a quick sketch, we know that this would be like this. The two values of x that we need are x, because we're saying either this is equal to 0, right, or x minus 1 is equal to 0, such that x is equal to 3 or 1. So we've got a 1 here, and then we've got a 3 there. Then we put the 1 rather here. So 1 here, right. So now we want the region for which y is less than 0, right? But what do we know? We know that the general shape for this graph would be like this, right? I want the region for which y is less than 0. Y is less than 0, this below the x-axis, which is here. And this region is defined by 1 being less than x, right? X being less than 3. So this region is defined between 1 and 3. So we write it as x being greater than 1 but less than 3. So this is how we solve for part A. And then now moving on to part B, we need to solve for the modulus of x plus 3 being greater than or equal to the modulus of 2x plus 2. So if we square both sides, we've got x plus 3 squared being greater or equal to 2x plus 2 squared. Like this. Such that if we expand, we've got x squared plus 6x plus 9 being greater than or equal to 4x squared plus 8x plus 4. Right. So now if we take what's on the left hand side to the right hand side, we've got 0 being greater or equal to 4x squared minus x squared, we get a 3x squared. And then 8x minus 6x, we get a 2x. And then plus 4 minus 9, we get a minus 5. So you can rewrite this as 3x squared plus 2x minus 5 being less than or equal to 0. Then now solving for x, we've got minus 15. Minus 15x squared, the factors that we need. So minus 15x squared. The factors that we need are 5x and minus 3x. This will give us a positive 2. So we are saying 3x squared minus 3x plus 5x minus 5 is greater or equal to 0. Solving for the 4-term expression, factoring out 3x, we've got x minus 1. And factoring out 5, we've got x minus 1 being less than or equal to 0. Such that x minus 1, 3x plus 5 is less than or equal to 0. Right, so we're saying either x minus 1 is equal to 0 or 3x plus 5 is equal to 0. So that we solve for the two values of x, critical values of x that we need. So here we've got x is equal to 1 or x is equal to minus 5 over 3. Right, so coming up with a quick sketch of what's happening here. The graph would be like this. Right, and then the 2 points of intersection with the x-axis, this is definitely the x-axis. This would be minus 5 over 3, and this would be 1. But we want the region for which y is less than or equal to 0, which is this region below the x-axis. So we see that this region is bounded by from minus 5 over 3 to 1. So we're saying minus 5 over 3 less than or equal to x less than or equal to 1. This defines the region that we want, for which the modulus of x plus 3 is greater or equal to the modulus of 2x plus 2. Okay, so this is how we solve equations and inequalities of modulus functions, and I hope this video is really helpful to you. Please don't forget to leave a comment, drop a like, and subscribe. Thank you.